Okay, class, let's look at these three examples, these three graphs, and determine whether or not they represent y as a function of x. Okay, so x is playing the role of the input, and y is playing the role of the output. Okay, so we see that example number one, this does not represent a function. Can you see why? Because you have these two red dots that are sitting on the same vertical line. Okay? What does that mean? Well, that means that when you take x equals 2, it is producing an output, a y value of 1, but that x value of 2 is also producing a output of 3. Okay? So x equals 2 is corresponding to a y value of 1, right? This 1 right here, but it's also corresponding to a y value of 3. Okay. So what is this? If it's not a function, what is it? Then it is a relation. Okay, and we can still find the domain and the range. The domain will still be the set of all the x values, the inputs. So I would go to each of these red dots and just read what their x value is. That's an x value of -2, reading back to the x-axis, -1, that's 0, that's 1. These both have 2 for x's, and that has a x value of 4. Okay? The range would be the set of all y values. So I'll just start here on my left side. Or we can go, since it's the y values, we'll read the graph from bottom to the top. Okay, so that has an x value of -2. That has an x value of -1. X value of, well, this one has an, I'm sorry, y value of 0. Both of these two red dots have a y value of 1, so we'll write it one time. That red dot has a y value of 2, and that would be 3. Okay, so that would be the domain and range for this particular relation. Okay, now here, example number 2, does this graph represent y as a function of x? And the answer is yes. Okay, you don't have any red dots that are sitting directly above and below each other, right? They don't sit on a vertical line. So my domain in this example for this function would be -3, -2, -1. That has an x value of 0, 1, 2, and 4. Okay? So that's the domain of that function. The range would be the set of all y values. So that would be -3, -2, -1. That has a y value of what? 0. Both of these have y values of 1, similar to the other graph. And that has a y value of 2. Okay, so that is the domain and range for that function. Now here, let me erase this just so that this doesn't get in our way. Does this represent y as a function of x? And the answer is yes. This graph is made up of many, infinitely many little red dots. Okay? And this graph certainly passes the vertical line test. Okay? The ruler will cross the red graph only one point at a time. So now, if I want to find the domain, I'm going to have to use interval notation or set builder notation, okay? Because there's too many x's to write down. Here we had 1, 2, 3, 4, 5, 6, 7 ordered pairs, so I was able to write down the numbers individually. Same over here. Okay? But now there are too many points here. So we have to write it efficiently. So this dot has an x value of -2. And as I move my finger along the graph, I'd have to include all these x's here that I'm highlighting with blue. And then as I move my finger along this red graph, I'd still be including all of the x values, right? So remember, for each of these red dots, you're reading back to the x-axis, okay, to get the x value. And so the domain would be made up of all these numbers that are highlighted in blue. That would be from -2 to 3. So your x's are greater than or equal to -2, and at the same time they are less than or equal to 3. Okay, so we can write it using set builder notation or interval notation with these square brackets, because the endpoints are included. Okay, and then lastly, the range would be the set of all y values. So since I'm writing y values, again, I'll read the graph from bottom to the top or top to bottom, it doesn't matter. I'll start here in the bottom. So that y value for that red dot is -2. Okay, and as I move my finger along the graph, I'd be highlighting all of the y values until I get to this dot that has a y value of 0, and then we're including all the y values that go all the way up to 2. Okay, so notice these dots here, there, and there, they all have the same y value, but that's okay, we only have to write them once. So really what we're seeing is the top here. So the green numbers go from -2 all the way up to +2. Okay, so the range would be all these y values that are in between -2 and 2, endpoints included. Okay, and then interval notation, it would be square bracket 2 all the way to 2. Right? So either way, set builder notation or interval notation works. Okay? But the focus of this video really was to check to see whether or not each graph satisfied the definition of function, which meant that the graph had to satisfy the vertical line test. All right?